Chapter 1. Our Picture of the Universe. In the first chapter of A Brief History of Time, Stephen Hawking takes us on a journey through the evolution of our understanding of the universe. He explains how humans have always been curious about their surroundings, constantly questioning the nature of the cosmos. From Aristotelian cosmology to the Copernican revolution, Hawking traces the development of human thought and observation, leading to the modern concept of the universe. Chapter 2. Space and Time. This chapter delves into the concept of space and time. Hawking introduces Einstein's theory of relativity, which revolutionized our understanding of these fundamental dimensions. He explains how space and time are interconnected, forming a four-dimensional framework known as space-time. Through thought experiments and relatable examples, Hawking helps us grasp the intricate nature of this amalgamation. Chapter 3. The Expanding Universe. Hawking takes us deeper into the mysteries of the universe by discussing the concept of the expanding universe. He explains how the discovery of redshift and the observations made by Edwin Hubble led to the realization that our universe is not static but constantly expanding. With a blend of historical anecdotes and scientific explanations, Hawking highlights the significance of this paradigm-shifting discovery. Chapter 4. The Uncertainty Principle. In this chapter, Hawking explores the fascinating realm of quantum mechanics. He introduces the Heisenberg uncertainty principle, which states that there are inherent limits to our knowledge of certain pairs of physical properties, such as position and momentum. Hawking goes on to discuss how this principle challenges our classical view of cause and effect, providing insights into the probabilistic nature of the subatomic world. Chapter 5. Elementary Particles and the Forces of Nature. Hawking delves into the world of particle physics, explaining the various fundamental particles that make up our universe. From quarks and leptons to gauge bosons, he guides us through the subatomic zoo. Additionally, he discusses the four fundamental forces governing the interactions of these particles: gravity, electromagnetism, and the strong and weak nuclear forces. Chapter 6. Black Holes. Probably one of the most captivating topics in astrophysics, the chapter on black holes explores the nature, formation, and properties of these enigmatic cosmic entities. Hawking skillfully unravels the concept of event horizons, singularity, and the behavior of light within the gravitational pull of a black hole. He debunks common misconceptions and addresses the recent discoveries surrounding supermassive black holes. Chapter 7. Black Holes Ain't So Black. Continuing his discussion on black holes, Hawking explores the theoretical concept of Hawking radiation. Contrary to popular belief, black holes are not entirely black and can emit a form of radiation due to quantum effects near the event horizon. With clarity and simplicity, Hawking illuminates this mind-bending phenomenon, shedding light on the interplay between quantum mechanics and general relativity. Chapter 8. The Origin and Fate of the Universe. In this chapter, Hawking tackles the biggest questions of all. Where did the universe come from, and where is it heading? He explores various theories, including the Big Bang Theory and the possibility of a cyclical universe. Hawking's explanations stretch our imagination and challenge our preconceived notions, inviting us to ponder the ultimate fate of the cosmos. Chapter 9. Wormholes and Time Travel. Hawking ventures into the realm of science fiction and explores the possibilities of wormholes and time travel. He explains how these hypothetical structures could potentially connect different regions of space-time, allowing for shortcuts or even journeys into the past or future. While acknowledging the challenges and uncertainties surrounding these concepts, Hawking presents them as exciting avenues for further exploration. Chapter 10. The Arrow of Time. In the final chapter of the book, Hawking delves into the concept of time, particularly the arrow of time, which refers to the distinction between the past and the future. He discusses the fundamental asymmetry observed in our universe and explains how time's directionality is closely tied to the increase of entropy. With his unique storytelling style, Hawking leaves us pondering the nature of time and its significance. Takeaway points. 1. The universe is a constantly evolving entity, and our understanding of it has evolved over time, driven by curiosity and scientific exploration. 2. Time and space are intertwined, forming a four-dimensional framework known as space-time, according to Einstein's theory of relativity. 3. The universe is not static but expanding, a key discovery made by Edwin Hubble that revolutionized our perception of the cosmos. 4. Quantum mechanics introduces a level of unpredictability and uncertainty into our understanding of the universe, challenging classical notions of cause and effect. 5. The origin, fate, and fundamental nature of the universe remain fascinating and open questions, inviting further exploration and study. Thank you for joining me on this awe-inspiring journey through A Brief History of Time by Stephen Hawking. If you enjoyed this video and found